going to show a few things here for, there's a few questions that's come up on their TruCut plasma group lately. It's kind of dwindled down, sadly, that there's not a lot of people anymore, and I think this guy's name was Philip. Let me go in here and look right quick at his name is Philip. I don't know how you say that name. Sorry, Philip. Cochran? Anyway, I won't try to pronounce it. But apparently they have got a table that they're trying to use. I guess they bought it used from someone, and they're trying to figure it out. And we've all been there. For me, it was about 5 or 6 years ago. Well, maybe not that long. I got my table in 18, so I guess that's 4 years ago, roughly. So anyway, let's get out of this, and I just want you to be aware of things. It's so hard when you don't have Ross in the group anymore to help, and Gary Ramsey was a big help. So number one, all of the files that you needed were in that, they always say was on your USB drive that came with the machine. Well, what if you didn't buy the machine new? And sometimes Ross is, I don't want to say he was lying about it, because I don't think he meant to lie about it. But he would say, oh yeah, it's on your USB. Well, some things were not always on that USB. He had people working for him that were pretty sloppy about doing things, honestly. And you can look at the tables and how they're welded together and built and see that workmanship, the craftsmanship, whatever, building those tables was pretty lacking in a lot of areas in quality. So Ross was a super sharp guy, and I feel like he did well probably when he was building them. I don't know. He told me he built about 1,000 tables while he was in business. So, but I think the people working for him didn't care, and so sometimes they didn't. And so you may not have these files. What I'm going to tell you, Philip, here is I have all the files that I could possibly save, and I've got them saved here in different spots. Let's see if I can see them real quick. But I want to show you some things that you already know, and maybe you don't. I just not trying to belittle anybody or anything else, but for any new people, I'm certainly not the smartest guy on this. There's plenty of other people that was in our group that know a lot more than I do, but I've just had to figure things out, and I really haven't had much help. I used to call Ross real occasionally. I've probably only called him 3 or 4 times since I had my table, and he always was able to help me get through whatever I was doing, and most of the time it was fairly simple. It wasn't always my fault. You know, one thing that Ross and Cindy always tried to do was blame it on, well, what'd you do to it, or you're doing something wrong. And it wasn't always the operator. Probably most of the time it was, but not always, and sometimes it was just a setting that they didn't have right in the machine to begin with. But that's beside the point, and that's been a long time ago. I'm just wanting to say, if there's people here that have files, and I think we're certainly can share them. I'm kind of locked up looking for these files. I think most of the time I have them in different places in here, but for one thing, you need to read the manual through. And if you think you don't have the manual, look on your hard drive that's on the computer on your machine, and most likely it is in there. And I'm not on that machine right now. I'm in here in my office. But I've saved a lot of times. I'll put that under, like this says plasma table. Okay, this Mach4 hobby. There's the licenses files and different things like that I've got in here. I don't know what this is. And I've saved some files more than once, but and there's different things. If you want to get on your machine and look through it, there's like mill G-code programming and Mach4 controlling. There's a lot of different things that's pretty cool. I'm trying to learn more about the milling part of things in case I can put a spindle online at some point, but here's some, that's not what I'm here to tell you right now, but I was just telling you that you need to read that manual through. So I've already got it opened up right here. I forgot about I already had it open. So if you look at the top of this, Philip, you need to look through this manual. This is really pretty good laid out manual, actually. And a lot of the things I didn't know early on, it was, even though I'd read this, I just have a better understanding of it now than what I did then, because I've just done so much stuff with it and I understand a lot of the things. If you read this for the first time and you don't really know for sure, and like Mach4 was the old Series 1 computers, I mean, controllers on the old Series 1 that had the old chain drive, as far as I'm concerned, piece of junk type computer, I mean, system, which people would argue that those were wonderful and great, but it's like any plasma, whatever they have, they think is great. So the Mach4 XT machines was the most modern ones that they built. That was the last versions that they made on this platform, not talking about their commercial type stuff. But if you read through this, I just want to show you that this is there, and if you need a copy of this, I'll be glad to send this to anybody. It was on your computer and on your USB drive, I'm pretty sure. This is really all we have that Ross wrote to help us know how to kind of use the machine, okay? Next is, I printed your G-code, Philip, that you were having issues with. And let me say, I'm going to have to put my glasses on because I'm an old fart that's blind. Old age. And for one thing, your post processor is an old version, and I'm not sure why that is. I don't know what your model machine you have. But let me pull up your, let me go down in here and find what you sent me. Let me close out. I don't even know what all I've got open here. So I think I downloaded those files you sent me. Here's I was working with plate 2, just messing with this. Oh my gosh. I don't know why I can't open that now. Let's see if I can say open with. Can you believe this? I don't know why I can't open it now. I'm looking like a real idiot. Okay, you can do Notepad or anything to look at that G-code files. Okay, so see right up here, you have revision 9B. That's an old post processor that you've got an XT machine. I don't believe that's the right post processor. I know it'll work, but it's an old. He's had 3 or 4 different revisions since then, I think. So I don't remember why or how I got my updates, but I'm sure it was when they had their website up I was able to find the latest stuff. But anyway, I wanted to go through this G-code and see if you understand what all of this stuff is. And then also, let me show you first what I did and how I got to what I did. So I don't have Sheetcam open, but I'll just show you. So I know that you watched the other video and it's probably the same thing here. I don't remember. I didn't watch that video again that you said you looked at. I don't even know what it covered exactly. It's probably the same stuff. Anyway, it's kind of quiet in here and my wife's probably going to be here in a little while, so I'm trying to get through this. So Sheetcam has been updated, and I've kind of put this back to classic. I wasn't sure what all this shortcuts was, so anyway, we'll see if I can get through this. File, you go import drawing, and I don't use this every day anymore like I used to. I rarely use my plasma table anymore. I have it out here to use when I need it, but it's pretty rare. I don't even have any water in it right now on the table. So, So we're going to import the file, which is this DXF file. I will say I use SVG files every chance I can because they seem to be cleaner files, but you know what? I don't even see that file. There it is. Okay, I know this one has bigger holes than your other one, and probably you had more problems with the other one. I don't really know, but just in case this is helpful to anybody in our group or anywhere that if this ends up on YouTube, that's just what you do. You import your DXF file, and you can zoom this up, whatever you want. I usually keep the screen as clear as I can with stuff. This code editor is where your G code will appear when you're done post-processing. I usually just slide it out of my way and keep this up here as big as I can. So anyway, in the first, I noticed, I don't know who drew this file, but it's not saying that it's bad, but when I draw something, I usually have it all on one layer. Maybe you move these layers, I don't know, but so you have your inside layer, see there it went away, and then your outside layer. I normally move them anyway when I have some holes. These are big holes, so it probably wouldn't matter. This hole, you know, if you wanted to measure it, is that's 3/4 long, and I think it's 3/8 wide or something. Yeah, it's not super small. This one's pretty big. It's 4 inches by something. What in the world am I doing? It's 4 1/8 by about, what in the world? That don't make sense. Let me do that again. Maybe it does. I didn't remember it being that big. What in the world am I pushing? Measure. It says it's 2 1/4 inches by 4 1/8 on that big hole. So anyway, those are pretty good size. And the thing that makes it hard to cut something like this without having a little spot on it is that everything on it has a big radius on it. You know, I don't know what size these radiuses are. It don't really matter. They're big radiuses. It's probably a 1 inch radius or maybe a 1/2 inch radius. I can't tell, but it's hard to put a lead on something like that without leaving a little spot on it. So I try to put those leads somewhere that hopefully they don't show up at all. So that's all I'm going to say about that, and I'll show you how I do those leads. And again, I'm sure you've already seen this and know this. So let me just get into it real quick. Now, even though these holes are bigger, I'm going to use the same type of methods that I would use on a smaller hole. Just for example here, and you can see these probably better than you could possibly on a smaller hole. And mainly the reason I'm doing this is the G code that you sent me. The one I printed the first page of was on plate number 2, so that's the one I'm doing here. So anyway, the first thing you want to do is go over here to create a jet cut operation. What in the world did I click? That's not it. Okay, and I noticed you were cutting 3/16 material. 7 gauge is what they call it in this tool. So I don't know why they show this tool list here, because you don't really use that in Sheetcam much anyway. But so we're going to start an operation on our inside. Make sure this says inside offset. Our layer is going to be inside, since you already have that layer up there. So we're going to cut all our inside features. This tool 26 7 gauge steel, that 45 amp, that is the right tool. This is exactly the way I would do it. And so if you'll notice, that says 70 inches a minute, and that's about right. 3/16 cuts 70 to 75 from my experience. And I know that on that screen you had on Facebook, it looked like this machine was set at 98 inches per minute. And so that's part of your problem, I believe, on some of those cuts you were doing. It won't cut 3/16 at 98 inches a minute on 45 amps. So, and that could be that you had that set on 65 amp, and I don't know for sure. if you have a 65 or a 45 XP or what, but yeah, on a 45 amp, you want to run that around 70 is about right, or yeah, 70 works great on, and I'm talking about big cuts, not on little holes or anything like that, but 70 is a really good number, and you want to keep that at 60 thousandths off the plate on your cut. So I know I'm getting sidetracked, but that's just something I observed there when I was looking at that. So to make that, we did an inside offset, and we're on the inside layer. That's the right tool. We don't mess with any of this stuff. We can do an overcut on holes. I would probably do an overcut of at least whatever the kerf is, and I didn't look at that kerf. I don't remember what they are, but let's just do about, I don't know, about 50 thousandths or so. I'll go ahead and put the third number just so it makes us think about what we're doing better. 50 thousandths of an inch overcut. That may be too much. I don't know. You can play with that and see how you like it. And then let's do, you want to make sure this is reverse cut direction, you know, like climb milling. Inside hole is counterclockwise, outside cut is going to be clockwise. That's the way it always needs to be. So your tool is to the left side of your movement when you're going. Just remember that you're always cutting to the right of where your tool is as you're moving along. So it has to be that way for it to cut clean as it can. Now on our lead in, usually on a hole you do a perpendicular. This is the way they teach. I'm not saying I made this up. This is the way I was taught. This is the way Ross taught me. This is supposed to give you the best result on a hole or a radius type cut, perpendicular. Now you can try both ways, and you don't really need a lead out on a hole. I think gives you the best result using a little bit of an overcut. Okay, so we'll do the lead in length. I don't know what length we need. Let's leave that alone for right now. We're not doing a lead out, so let's say okay. So that's not very good. That's too long. You want your lead in to be half the distance of your hole. Okay. So right here is fine, but I don't, on something that big, I probably don't even use a perpendicular. So we'll go in and let's just double click back in here and let's change this. I think that was a 3/4. Let's go 0.3 inches on that lead in, and let's change that. I didn't change it, did it? What did I say that whole length was? I've already forgot. Yeah. 0.3. Huh. Oh, that's only 3/8 wide, isn't it? So that radius is 3/8. So yeah, this needs to be somewhere around 0.15 on that lead. Okay, now I don't like it being right there. To me, if the more of those leads that you can put down in the end of this, the less visible they probably are. You know, if they were on along this edge, they're probably more visible to people. If I worry about how stuff looks all the time, you know, so just to get the best result, I would put it right down in the bottom of this. You can do anything you want, try anything you want, see what result you get. But so you go over here to start, edit start points, and so you can move this to anywhere you want like that. And same thing here. And I don't like this lead, so we're going to change it anyway. So, but if I was going to use those leads, that's the way I would do them, is right down in the bottom of that radius. All right. Since we don't like this one, let's right click on that and go to properties. And it says use operation lead in. We're going to uncheck that. We're going to make our own. I think I'd probably go ahead and use an arc lead in on this one. And we could use a lead out and see what it does on that. But let's make this a pretty, yeah, 1/2 inch is a pretty good size. Let's see what that looks like. Let's just go ahead and put an arc in there and see what that looks like. So normally you can't do very good on a radius, like I've said before. Sharp corners are pretty easy. any type of a arc is going to leave you some kind of mark that's hard to get away. But if it was down in here, if you wanted to, you could come in here with a die grinder and blend that stuff out and probably never find it, if it was important enough to worry about. If not, that's probably going to be your best bet to do something like that. And if this was just a really tiny small hole, I probably would do the perpendicular and do an overcut. Now, we don't really want an overcut on that. Let me get back to, let's do that properties. And see, they've changed up this program so much with the updates that I'm not sure. Where is the overcut? No. Override. No, there's no overcut, I guess. Even if there was, I'd probably just, I don't guess there's an overcut. Anyway. No, there's not an overcut on that one. Let's see if there is on these. Yeah, I think there's an overcut right there. So anyway, well, I was going to say, so try that for just pretend that's a circle. That's how you cut circles, do a perpendicular lead. That's at least the way they've taught me. Then let's change this one to a different one. So you could cut that. You've probably already done cutting this. I'm just saying it on anything. Just for an example, go ahead and change this one to something different. So go ahead and unclick that. Let's just put an arc in there. And I wouldn't put a lead out. I'd still do an overcut. I don't know where that overcut is. Let's change that overcut to, I don't know. Let's do 30 thousandths overcut. I don't know how much it needs. Whatever it covers, the curve probably is enough. Wow, that's a huge. Go back in there and look at that. I messed up. Yeah, we don't need much of a lead on that, so 150. 1.5. Put the third number. I like those. 150,000 lead. Okay, see, now to me that looks a little bit better. That gets you more away from the material than that longer lead did. So you're starting a little more towards the, you know, I wish it would start more in the center and then come all the way around like doing a circle, but I don't know of a way to change that really. So anyway, I think that might actually work better. I mean, you would think it would by looking at it, but they've always told me a perpendicular lead works better on a circle, so I don't know. It's probably not enough difference to matter. Okay, so now remember we need a variable on holes. We're just pretending these are smaller holes, but in this case, let's just go somewhere around 75%. This is not a fast cut anyway. So if we're at 70, now remember the machine sets the feed rate, so that percentage you can play with on your machine. On Mach4, look at that percentage that it's set at, and you can, every time you bring the G code in, you can change that percentage, and if you don't like it, then close the G code, change that percentage to say 90% or whatever, and bring it back up. So, and that'll change your feed rate. But let's go to 75%, and remember you have to drag this at the first of your deals. So now we're going to be at 75% of, let's say 70. So we're going to be, I got a calculator here just for instance. So 75 times, what was it? No, 70 inch per minute times 0.75 is, we're only going to be at 52 inches a minute. That's pretty slow, and that's too slow for cutting this. So I wouldn't do that. Honestly, on that cut right there, what I would personally recommend is change that. I don't know if you can change that in here. Actually, you can't. I hate to just dwell on something like this, but I'm just trying to make sure you understand. This is such a big circle. wouldn't recommend cutting it that slow. You can if you want. You're just going to have more slag and draw some crap on the back side of that cut. It'll cut fine. It's just, to me, it's a little too slow. So on these holes, I probably would, because they're only 3/8 wide. And even that's pretty slow. But in this case, what I think I would do is, edit contours. Remember how you do that right here? Edit contours. What I would do is right click, move that to a new layer. If you want, this is just examples. This ain't saying this is how you should do this. Let's just put big hole. I know it's not really a hole, it's more of a slot, but let's just say big hole. And so see right there, that's that big hole. And now what you could do would just say, now we need to change this variable back to 100. Now remember, when you turn your variable off, anything below 100, it turns your torch height control off. And on some distance that your torch is moving around on, you may want that on to make sure it's on the same plane and it's not gonna dive or drag the material or anything like that. So hopefully this is helping you. Maybe it's not just a nuisance to you, but so this is on its own layer, and I know this is a lot of time and you wouldn't want to necessarily do this. You could just throw this on there and cut it and it should work fine anyway. But those holes there are fairly small, because they're 3/8 wide. But let's just do another operation on that layer, and let's just say it's still an inside offset and it's on layer big hole. And remember, we were going to do an arc on that one and an arc out. And let's just leave that a pretty good size lead at 0.5. And let's don't do an overcut. So let's put that at 0. And that's all, I think. And remember, we wanted to move that, so you go to start point. Oh, I'm not on that layer, so I need to be down here on this, on that operation. Now, see where that kind of snaps to that center of that arc. So that way it's going to come in and lead in there, make the cut, and then it comes back here. It's going to lead out right there. Okay. Sorry if I'm telling people things they already know. I'm just trying to be sure. I'm covering different ways of doing things. See, we got a perpendicular there, and you may not see a hill of beans difference in that, but if you do two different methods on the same part, at least you can look at it and go, yeah, that made a difference. I think I like that way better than that. Or maybe I should have put a longer or shorter lead, or more or less overcut, to see if that would blend a little different there. I mean, this is fire cutting. This is plasma torch. Don't expect this to be like a machined surface or a laser cut or water jet. This is plasma. It's just, might as well be a cutting torch, It's not perfect, but it's pretty good. So in this case, all we've done is cut all the holes out, so we need to do another operation. Now, we're already 100% on our feed rate, so we don't need to mess with anything else on that. So let's just go in and make another operation. Let's go outside offset on our outside layer. And it's looking like it's going to do no overcut, which is fine. Let's do some pretty big leads. 1/2 inch might work fine. Let's try a tangent lead in on this one. Let me show you that. And an arc is probably fine to go out on that one. So let's see what that looks like. It's going to put it in this goofy place, and I almost never like where they put those. So let's move that one. I would put it right here. Remember, you got to click on the operation you're talking about. But see how that wants to do stuff like this? Now, if you don't like it down here off the material, or be sure you line your material up where this lead out will work. But see how that's going to be a smooth cut. Let me just click it right in there. But see how that's going to come in straight in on the material and just start cutting. And when it comes all the way around, it's going to come around the corner and then kind of lead off of it. So you're going to have a little bit of a little pip spot of some sort right there, but you know what? That's a pretty much a perfect spot that you could take a little grinding wheel or anything and just blend that off if that was bad enough. It may not be bad at all. Yeah, but you can play with stuff like that and see what you think about it. You could even put big leads up here, and wherever you want to hide that little lead in or lead out is where I would put it. Now, if these were sharp corners, I would put tangent on both spots, so you know it's going to come straight in, and when it comes out, it's going to go straight off. And probably there's settings, if you'll read the manual, on when to make the torch come on or off. Sometimes they want the torch to come off at the right point of when it, I guess, is about to clear the material or something. But that's a little more difficult to understand. I'm not an expert on that for sure, but it does talk about that in that manual I was telling you about. So now that you see how I did this, and you know, all you do at this point is you run the post processor, and it's going to just name it something, and I'm just going to, I've already saved this, not this time, but let's just save it. I'll rename this again for, I don't know what version this would be. I'm just going to put it a V because that's when I was making the video. And let's just save that, and that's in my OneDrive G code, so save. Okay, now once you push OK, then your G code shows up right here, and you can print it, edit it, whatever you want. Now this is where I want to kind of dissect the deal. So let me see if I can pull up your G code here. I wish I could pull it up on the same screen and we can kind of look at them. Okay. Now, number one, if you'll notice, your G code says revision 9B. Mine is revision 9F. That's your post processor that Ross wrote up. If I was you, I think I would update it and see if that helps any of your trouble. He's debugged some of this stuff, and I could go in and look for that G code, and sometimes there's some notes about what he has fixed with the post processor. But if you have an XT machine, as far as I know, that's what this post processor is for, this 9F. You may want to save that or make sure you have that file backed up somewhere. But I would update it to this revision. If you don't have that, holler at me. I can send you that file, I think. See if I can find it. I mean, I know I have it somewhere. So, and we can step through how you, if you will look at, Ross actually has some good videos. I'll show you those in a minute if I get it time. I hate that this video is getting so long. I don't blame you if you don't want to watch it, but I'm just trying to be as helpful as I can because of the questions that you seem to have on some of this stuff. Talking about Philip or TruCut, anybody with a new TruCut machine that they haven't had a lot of time with or experience with. So anyway, here's the same part that he made with his G code over here, and this is one that I just made on the video. So number one, if you don't know much about G code, some of these are a little weird compared to like normal milling machine G code, but let's just start dissecting this and see if we can figure it out. So number one, G20 means it's in inches. If it was G21, it would be in a metric, meaning all the moves were in millimeters instead of inches, okay? But we're in G20, which is this first part of usually any code is your safe, basically your safe code that puts the machine into what's kind of considered a safe mode, meaning it's canceling out anything that might be in there. It's just starting it fresh. So G20 is inches. G90 means we're in absolute mode. So we're moving from 0 to wherever that point is on the plate. G91.1 is an increment move for doing these circles, which is the GO3s and the GO2s and stuff, which is arcs. GO3 is a counterclockwise arc, and GO2, which would probably be on our outside cut down here, would be that's going to be a clockwise move. So Being in 91.1 is how a lot of times there's different ways of doing it, but in this case, that means they're calling up, when they call G03, they're saying at this point right here, we're at X blah blah and Y blah blah, and this I right here is going to be the point of the circle. I don't want to get into that stuff, and I barely know what I'm talking about, but I is your X and J is your Y, and so that point of the arc is where that is, and this point of the arc is on the X. That point of is where it completes on the Y. So those are all done as we just went through, and it done it automatically for us. And you can write this. So that's what that means right there. M11, I made some notes here because I wasn't sure. Anytime you see an M code, that means it's turning something on or off. G codes are kind of commands in G code for the machine to do something, usually in a move, like a linear type move or something. And a M code is just turning something on or off. Like M8 on a mill would be turning coolant on. M9 turns coolant off. Of course, we don't have that on this, but I'm just telling you what M means. So M1100, in this case, that is just kind of part of, again, part of the safe mode of starting the machine up. That's just saying torch height control is off right now. Commanding torch height control off is M1100, I'm pretty sure is what that means. Now, notice on my code here it said M1111. This is in that manual. Part of that is in this manual. If you haven't read it, at the bottom of your manual is a bunch of this G code. See, this is the manual that Ross wrote for these XT machines. And I thought it was at the bottom. Let's see where it says, page 45. So we're almost there. See right here, this is a list of some of the G codes that you'll see coming up. So, like I said, 11. See, he didn't put 1100 in here, but I kind of figured out that's because 1101 enables torch height, and so 1100 is probably just means that it's off. 1102 says disable, and I don't think I ever see 1102 in here. So I think 1100 is just we're not commanding torch height control. Basically, I think is what it means. So I don't think I saw any 1102. We'll look. Anyway, I'm just telling you these G codes are in here. That says set cutting torch offset, and I don't know why that's in your code. I don't know that it's in mine. Let's see. So you have M1111. That's another thing that makes me wonder if there's something funky about your post processor here. It could have been an old way he did something that he's changed, because we don't have M1111 in here. We only have M1100 on here, so that means, pretty sure that means torch height control is off. So now we're going to, remember this is your code on the left here. So then the next is a rapid move. GOO is a rapid move. It's going to move to X 0.4375 and Y position there. And so, because I probably wrote this a little different, we're not in the same position because yours probably started at a different point for whatever reason. So I think I've got a code that I had down here. I may have already closed it, but I saved one that I came out here and I made some notes in here to explain what all this stuff is, but we can go through it right quick anyway. What you can do is you can edit this right here in here if you wanted to. So what I kind of did earlier is I just put that there and just hit the enter button and separate this out a little bit so you can kind of see how this code is written. And maybe you don't care about this, I don't know, but I'm just trying to make you understand what's going on here. So you can kind of go through here, and if you'll notice, there's an M01 at the end of these codes, and that's kind of important because the reason that's there is so you can start. If you was to start it, you can see it says run from here. It says run from here, start point. So if you have option stop on Mach4, you can turn optional stop on, and it will stop the program right there after that cut. And if you needed to do something, it's going to stop after every one of these shapes that it cuts out. It'll stop. And you could do something if you wanted to worry about if it's going to have a flip tip up or something, you need to get some pieces out of the way or whatever, you could actually have optional stop on. So, and you know, I've never really thought about doing that before, and that's actually could be pretty useful to do that. And it'll stop every time, and all you do is go hit cycle start, and it'll go to the next one. So anything in parentheses here is not part of the code on any G-code machine. It doesn't read that as anything. So anytime you want to put notes in somewhere, just put them in parentheses like that, and it might be helpful to know what you're doing or something like that. So anyway, so that's what M14, we didn't go to that. M14, let's see what I've got down that means is, okay, that is initiates cutting sequence. And that was in the manual, remember, that I told you he put all this in the manual. So I didn't make all this up. It's right here in your manual. So M14 just means initiates the cutting sequence. Now remember, M codes turn things on or off. So what I can assume that's happening here, this initiates cutting sequence. So let's look at the G code now. And what this is weird stuff right here that doesn't make sense to anybody. As far as I know, A0 and B75. Now B75 is because we turn the feed rate to 75% of what Mach4 has it set at. So that's 75%, and if you'll notice down here, when we went to our outside cuts, and even our big hole that we were at 100%, that's the only difference here is that's at 100, and then you have M1101 here, which means torch height control is on. If you'll notice all these other codes, they never did do that. Now, once the M1100 was set, it doesn't have to set every time. That's kind of that's a modal, they call it, type code. So until the M1101 comes in the code, it's still torch height control off. It's disabled. Once the M1101 comes on, that's when torch height control comes on. Now, if you was to change this back to 100, that would be at 100%. And you could just say, hey, I don't like that, and probably manually edit that code, maybe even out on the machine. I haven't actually tried that. You could probably change that to B100, and it would all be, and change this to M1101, or find out in the code where that comes on. You know, you could play around with that. Like right before it comes in, right after that initialize the cut. Now this code, this M14, like I said, it says initialize or initiates cutting sequence. That's what I was trying to get at. M14 means it's turning something on. So what that's doing is turning on a module that's in that box that, as far as I know, none of us understand all of those controllers that are inside the end of that plasma table. That's a bunch of crazy electronic looking stuff but one of them modules has software built into it that this is telling it to do something. So it says M14 A0, that's the feed rate, I know that much. So that's the Mach4 controller. I guess it's the Ethernet, what's he call it? Smooth stepper, I think is the name of that type of module. He talks about that in the manual. it's just initiating a code to it to say, okay, we're fixing to fire the torch. We're getting ready to cut. That's what that code right there means, M14. And then this is just the moves that it makes to do whatever shape we're cutting here, which was the first hole or slot, whatever you want to call that. So then it did all that, and here's our M1 again. If we had optional stop on it, would stop right there. But or if you wanted it to stop for sure and you wanted to go in another room and do something, you could put MOO right there. Just edit that to MOO, and it would stop. No matter if optional stop was on, it would just stop until you hit toggle start, and it would start again. So, but I'm not going to change that right here. I can send you this file if you want to try this cut. If you'd like to have it, that's anyway. But I'm just showing you what this stuff means. And then we're going to go to a rapid move, and it's going to move to the next position, which is the next, which I don't know where we're at. That's on the first one. I guess it's the one over here. So see X 5 inches this way, 5 and nearly 3/4 inches this way. And then it's going to initiate that cut. Oh, if you didn't notice the M15 right here, that meant to cut sequence is off. So it turned off the torch and all that stuff that it was, whatever that module is taken care of, that's what M15 is right there. So then it did a rapid move. Now it reinitialized the cutting sequence here, did that shape, turned off the cutting sequence. Anyway, on and on and on. That's just what that stuff means. M1101 right here, like we've already talked about, that's turn torch height control on. Because see, we were at 75% there. So those first two holes where torch height control was off. And then we turned M1101, meant that turns it on, because see, we're at 100% feed rate. We did that shape right there, which was their big hole. Right here, this big hole, big slot, whatever you want to call it. M1101, and it did that cut, and it stopped the cut. Now remember, 1101 is going to be on now, from now on, because that's a modal code. So it's going to stay in effect until it's changed back to M1101 or any other thing that turns that off that's built into the controller. So anyway, I like to separate this so you can see these a little bit better, but just to break down what that code is doing. And that may not be very helpful for you, but that's just something that I figured out here by looking through this. And you can do the same thing looking in that manual. Just takes a little time. So anyway, if you'll notice after that last cut down here, I don't know why it has M1101 on again. I guess because it was a different layer, and so it just put it in there again. So down here, M1109 and M1105 is not, I don't think it's in the manual, but I can tell by those numbers that that has something to do with just turning stuff off because you're done with the cut. And this rapid returns you to X0, Y0, and you could change this X and Y to some different numbers if you wanted to, for it to not go all the way back home. Just say, you know, change these numbers, or just probably get rid of that whole line and it would just stay, it'd turn off. But M30 just means it's going to end the program and rewind to the first of the program. In case you want to run that same program over and over, M30 just resets the program, puts it back to the first of the G code. All right, anyway, that's all there is to that. So let me look at these notes. Also, as far as a lot of stuff in that manual that you may need to study up on is, I made a little bit of a list, but airflow, anytime you're losing a cut, I have had to clean out. I've got a refrigerated dryer supplying air to my machine. One time I think I had to, I don't remember if there's a little filter on it or what, kind of blow that out or clean it out. And also on the back of your, if it's a 45 XP Hypertherm, there's a little filter on it that even though you don't think it's restricted, I have had mine to quit cutting here and there, and it was because of restriction with the air. And also, what else did I put? You can reference that torch height, and I put that as page 16 and page 42. He talks about how to set that torch to be sure you're at the right pierce height, because at cutting height it don't matter that much, because the torch height control is taking control of that depending on how you've got the voltage set on that. So page 42, he talks about calibrating the pierce height. So all you do is find something that's a certain thickness that you know for sure. Say if it's a 1/4 inch piece of material, or it could be a 1 inch, like a 123 block, or just anything that you know how thick it is that you can slide under the torch. So you go up to, see on page 16, I think he shows you on the controller. Since I'm not at the machine, I can't show you this right now, but I can show you how you do this if you haven't already done this. You go to where it says settings right there, and then you do reference torch, but don't push that until you're ready. So this switch offset number, now don't lose any of these numbers that are in here if you change any of them. Write them down, take a picture of them with your phone, do something here. This is just the number you're going to change to make that calibrate. So change, let's see, one of these numbers you set the height to, okay, there's the marker height. That's at 0.15. That's what we normally set them for, a fairly normal thickness of material that we're cutting at 150 thousandths pierce height. So change this right here to 0.25. Now you need to read this, make sure I'm not crazy, but I believe that's that's where you're going to set that. So just change that number to 0.25. So that's 1/4 inch. And then push reference torch with nothing under there except against some solid material, but nothing underneath it other than that, okay? Now, after it does that, it's going to bring it right back up to hopefully 1/4 inch. Now slide whatever you had as a kind of like as a feeler gauge or a thickness gauge under that and see if that really was pretty close to 1/4 inch. Now we don't have to be within a thousandth here or nothing, but was it pretty close to 1/4 inch? Was it too high? Was it too low? You know, something like that. You may even want to put something a little thinner so it doesn't kind of like crash against it. Well, you're not going to crash against it. You're just going to see where it ended up. So anyway, so depending on what that number is, then that's what you want to change this to. So I think you're going to change, if it was too low, change this to a more positive number. You see this is a negative. Make sure that's always a negative right here. And it talks about that in this manual right here. But so change that. If it was too low, I think you would change that to a more positive number. If it was too high, change it to a more negative number until you get that real close. So that's going to make it pretty accurate when it's piercing or when it's cutting with the torch height control off. That's kind of how you set your torch height. And you may have already done all that. I'm just looking through things that I'm thinking could cause some weird problems. Also, there's things in here about your torch height control settings, and I don't remember what page that is. But there is some info in here about the torch height control settings. Make sure they're set. I don't never mess with my settings, so I'm not sure what they should be. But if you need me to, I'll look at what mine are at sometime and I can tell you. Also, the TOM travel was also on page 16. I got to thinking about that. That might be good to set that at a safer number, especially if you worry about that bottom switch messing up or something. Mine got messed up because of so much water, I guess, hit it all the time that the switch quit working and it was not very reliable, so I just bypassed it because Ross didn't act like he wanted to send me a new one for some reason. It wasn't very long before he went out of business. I bought some more online somewhere since then, but I didn't like that switch anyway. But that kind of keeps it from diving down and basically bottoming out the torch down into the table. But the TOM travel right here is set to 5 inches. That's kind of like telling it how far am I going to go down to look for material. So if you figure out about what distance that torch is moving from, I guess from its home position at the top to where it touches material, you probably just set that to a little less than what the material thickness is. And that way it shouldn't ever go down any farther than that, hopefully. And your safe Z just means it's going up an inch above wherever the plate is, I guess. Anyway, I'm not going to go through all that. I don't know that much about all this stuff. I'm just looking at it and figuring it out. So, and then like I said, your post-processor version to me is a little bit old. So holler at me sometime and we can get, you might just call me some weekend and we'll go through some of this. I'll tell you what, I can send you these files that you need if you need them. You may not need them, I don't know. So to run G-code from here, there's also a pretty cool deal where if you had a problem and you stopped for some reason because you had a problem, you can go back to your work home. Don't go back to home. Go back to the work home position, which is on your screen. And I'm not at the machine, but here it is. Go to work 0. It says right there. As long as you didn't reset or do something crazy, you can go to work 0. If it'll go back to where it started, then you can go down in your code and go run G-code from here. And it tells you in here how to do that. But basically, you go to the screen here. You click your X and your Y or whatever and push move. Don't do your Z. You don't want to do. Just move to selected. Click that, and it'll move to that spot. And just do a dry run or something to find that position in your G-code. And that's what you do. You click on that line of G-code, and then that's where you go to run G-code from here. You click that somewhere on this screen. Run G-code from here is right here. And so make sure you're on that line of G-code, which I don't have the machine on, so I can't show you. But anyway, that's pretty cool function that works pretty good. I've done it several times when you have problems. You say, I just want to stop and I want to let that rerun that little spot because it didn't quite cut it right or something. Or it had a little tip up that messed up the cut, something like that. Sometimes you can just rerun that cut, and it may not be perfect, but it might save your project. Kind of like the ones you cut the other day that didn't seem to cut through good. You could just rerun those, and they probably would be okay. So now, that's pretty much all I had on today. I hope that wasn't too long, and hopefully it's helpful in some way to you. So anyway, if you have any issues about this, I may not put this on YouTube. I don't know. I may just send you this video and see if you want to look at it and let me know what else you might need. And if you think this is useful enough to put on YouTube for our TruCut group, I can do that. I just don't know if that's what anybody needs to see. So, alrighty then. Good luck with your issues on that thing. So, see you next time. Well, I went ahead and turned on the machine out here, so I'm going to have to go handheld. I can't find my... Oh, I've been looking everywhere for my GoPro, and it's out here on my desk. I've looked over here like 6 times. Anyway, there it is sitting there. I've literally been looking for it for 30 minutes, but I'm about to blame my wife for moving it. Anyway, like I was saying, I wasn't on the machine earlier, so here's my machine. I don't use very often anymore, but I can. Works fine. See, there's no G-code pulled in here, so see if I can remember. And these headings, yeah, this is in your Run tab, so you can enable things here. Usually you can turn crash sensing on. It's probably the safe way. It may or may not cause things to happen. One of the main things I do before I run is, because this crash sensing head here has 3 contacts where these wires are here, there's 3 wires. Before I even run this, a lot of times I'll take a piece of sandpaper and just lift that up and get that in there and kind of just make sure those contacts are clean, because that a lot of times does cause trouble. You know, you can just tilt it up and clean it, especially if one's been wet or it's been sitting, or just any time you're going to use it. And the way you check that is, see if I can get this over here, is when you're moving it like this, look on your screen here for this contact light to come on. So somewhere, see, right there. When I'm moving it, watch this. See that light flashing? It should go on and off. So move it in about every direction repeatedly and see if it comes on and off every time. If it does work every time, it's probably okay. A lot of times that light will stay lit. And yeah, that's going to cause weird problems to happen while you're cutting. It's going to stop the cut, and maybe some of the things you're talking about actually is going to happen. But I know I've mentioned in the first part of the video there about when you bring in your G-code to turn this percentage on, and let's see if I can see. Here's the process. Okay, you go to that process tab right there. And then right here's your percentage speed reduction. I think Ross used to have that down at 70%. That's a little too slow. And what that's going to do is when you pull your G-code in, it's going to change your plasma feed rate here to some weird number. Now you can probably just change it right there. I'm not sure if that's going to change it the whole time or if that's just going to do it for every cut. I don't remember that for sure. I know this feed rate that you slide up and down, I believe that just changes it for the cut that it's on. But the best thing to do is set this percentage here. So it's at 95%. I think that's where I like it to be most of the time. We'll see. So when I pull the G-code in here, so right over here, see where it says load G-code? That G-code ain't really in there yet, but let's see if I can pull it from OneDrive. I mean, it's in OneDrive. I usually put it to the machine there. Let's just do that before I do that. So, you know, I saved it in G-code on my OneDrive, so that's that file. Let's just go copy, and let's go back to the desktop. I like how this Windows 10 has changed where stuff is. Should be right there. Let's just go, oh my gosh, that's a pain in the butt. Let's just go here to the desktop and find it. That's just where Ross had it. Right there's G-code, paste. So now it's in there. Go back in here. Okay, now let's load the G-code. So remember, that's on 95%. So I think that whatever Sheetcam said it was 70, it should be 90% of 70 is what's going to load. So load G-code. There's that file. There. So now, see over here, that's got that selected at 67. I'm pretty sure on that video I saw on Facebook that Philip had on there, that was running at 98. Well, you can't cut 3/16 worth of flip at 98 at all. You have to have that at about, you know, 65 to 75 in that range. Man, my finger ratting away of you, isn't it? So anyway, you know, if you change that number right there to a higher number, then that will be higher. I think that'll work just fine right there, just 95% on this particular thing. And I just keep on sticking my finger in the way. See that? Here's your process. That's 7 gauge and all that. So your offsets, let's see what all's in here. Outputs. You can have you don't want to mess with that right there. One thing I do in here a lot of times, I'll turn the laser pointer off, so it ain't just on all the time or whatever, or on if I need it. Yeah, so you don't require homing to be on or anything. Axis limits override, you can have that on if you want, but probably dangerous. Anyway, there's the file and it's ready to cut. And I know it's hard to see on that screen, but there's the thing it's going to do. I don't have my air on right now, so I can't do a motion, but I know I wouldn't have any doubts that that'd cut just fine right there. So I'll go ahead and send you this file and see if you want to. I don't know if you're done cutting this stuff or not, or if you got a lot of them to cut, but I'll go ahead and send you this file over, and I'll send you this video. It's about an hour-long video, so I don't expect that you're going to want to watch all of it, but hopefully at least some part of it is beneficial to you. So, alrighty, well, it's Sunday now. I better get ready for church in a minute, so see y'all next time.